This is problem number 70. The problem is there's a soccer ball that weighs 0.45 kilograms going downwards at negative 20 at 25 meters a second, and there's a player who's jumping up at 4 meters a second who weighs 60 kilograms, and the collision is an elastic collision, so they won't stick together. So the question is, there are two questions. The first one is, what will be the speed of the ball directly after the collision? And the second question is, what is the acceleration of the collision what is the acceleration for the ball during the collision, assuming that the collision lasts 20 milliseconds and that gravity is unaffected in the collision time. So first I laid out my our givens. So you have the ball, which is the ball and the player. So I had the player be m1 and v1. So m1 is 60 kilograms, and the initial velocity of this player is 4 meters per second upwards. And so I define upwards as positive. And then the ball is 0.45 kilograms and is going 25 meters a second downwards. And since upwards is defined as positive, then that means the velocity of the ball is downwards. So because it's an elastic collision, the momentum equation is m1v1i plus m2v2i is equal to m1v1f plus m2v2f. And so because of course in elastic collisions the momentum is conserved. So I plugged everything in using 60 kilograms and 4 meters a second for the first one, for the first mass, and then again I used this for the second mass, just plugged them in, and then I plugged in the mass, but not the velocity for the final ones because we don't know the velocity yet. And so then I just simplified these two, I multiplied them out, and then I just added these two together. So 228.75 kilograms meters per second. That's the velocity of that's the total velocity of what these two equal. So that's the total momentum of what the added momentum in the final, because it's conserved. And so because of how much they weigh, the velocities will be different. And so again, and now kinetic energy is also conserved because it's an elastic collision. So again, kinetic energy in this format, it can be simplified to v1i minus v2i is equal to v2f minus v1f. And so I plugged these in because we know the initial velocities, but we don't know the final ones. So, and then you simplify it a little bit, and then you get v2f minus v1f is equal to 29 meters per second. And then I set v2f equal to everything else, so that v2f is equal to 29 meters a second plus v1f. And so then I substituted it into the earlier equation. And so we have 228.75 kilogram meters per second is equal to 60 kilograms multiplied by final velocity, v1 final velocity, plus 0.45 kilograms times the quantity of 29 meters per second plus v1 final velocity. Because even it's v2 here, but you substitute it in, so you only have one variable, so you can find it. And then here I multiplied it out, and the next step, I moved the 13.05 kilogram meter per second to this side. So I subtracted 228.75 kilogram meters per second by subtracted 13.05 kilogram meters per second from it, and then I added these two up, and then I switched it around so it's a little easier to see. So 60.45 kilograms multiplied by the final velocity of the player is equal to 215.7 kilogram meters per second. And so then you divide both of them by 60.45 kilograms, and then you get the final velocity of the player to be 3.568 meters per second. So that means 3.568 meters per second up after the collision. And so then you plug that into the earlier equation where you knew that the ball's velocity is equal to 29 meters a second upwards plus whatever the player's velocity is. And so I plugged it in, and then here the speed of the ball after the collision, the final velocity of the ball, is 32.568 meters per second. So now we need to find the average acceleration if the collision took 20 milliseconds, and this is assuming that during that collision gravity just wasn't there. So because each millisecond is 1/1000th of a second, and there's 20 milliseconds, so 0.01 multiplied by 20 is equal to 0.001, multiplied by 20 is equal to 0.02 seconds. And then I have the initial and final velocity, and so then I use just the kinematics, and then you just divide, you plug everything in, you isolate A, and then you find A to be 2,878.4 meters a second squared. And so the average acceleration is 2,878.4 meters a second squared.